Welcome at the lunch reading, the lunch lecture. At first, one question, apart from this one. If I don't know the English word and I'm stumbling and I'm searching something, who can help me? Really, no one. You're all? You might be able to, okay. Okay. Okay, at least one then, okay, thank you. First question, real question. How many of you think you're going to be an architect or have the ambition to become an architect? Hands, show hands please. Oh, only 7, okay. Well, in my first year, would have someone have asked this question, we were with our first lecture, we were with 150. These times, I guess, 300 in this department each year, but in our time, my time, long time ago, 150. They would have shown all 150 hands. So, some more questions. Have you got any idea how many people are working in construction industry in the Netherlands? Who's bidding? What are you bidding? Who bids 1,000, 2,000, 10,000? Anything? No ideas? How many colleagues you're going to have in the future? No? A lot. How many companies do you think there are? 500, 1,000, 2,000, 5,000, 10, 100? How many? 1,000. Okay. So the first few disappointments. There are 320 people working in construction at the moment. And they are a lot of what we call in the Netherlands ZZP'ers, because that's 194,000 companies. They can all be that serious, I guess. Any idea what is the turnover? How much money is going around in construction industry in the Netherlands? Let's talk about billions. Per year, of course, yes. Anyone? 10 billion. Who's bidding more? Who's bidding less? No? Okay. And that's the English word is gross net profit, I guess, or something like that, but in Dutch is BBP. So what percentage of the Dutch economy is construction? Who's bidding 1%, 2%, 3%, 4%? 5, okay. It's about 76 billion euros a year. It's from housing, industry, and of course roads and civil constructions. And then the main question: how much do we earn in construction, and how much do we waste? Any idea what the consensus is about the percentage of waste we have in construction in the Netherlands? Any ideas? 1% waste, 10% waste, 20% waste, 3% waste, 20%. And the margin, what do we earn? 10%, 9%, 8%, 7%, 6%? Who's bidding less? Who's bidding more? You don't have a clue about the numbers, I guess, do you? Whatsoever, okay. Well, this is about realistic at the moment. So, the numbers about the waste, so the failure costs. Of course, all these companies who are interviewed themselves tell the most fantastic stories, and these stories end up at maybe 5%. But I, maybe not even so long ago, interviewed someone for our company to become an engineer at our company who had been working at a contractor, and she said, well, in our company, I think it's about 25%. So there's a lot to do for us, and if you waste a lot and you don't earn much, you would say, well, there are a lot of opportunities to do things quite a bit better, maybe use technology or whatever. Well, that's even still complicated. It's not so easy. Construction is a trade-like industry. Maybe even would tell them would tell it is quite a conservative industry. Of course, all companies like mine also, we tell we are very innovative, but if we do it actually in practice and projects, that's question number 3 or 4 or 5. This is productivity. This is a recent schedule. You see that the development of productivity in any other industry, except from construction, changed from 96 to 2018. Well, it doubled, just about. And in construction actually something is really happening because it has been changing the last maybe 5 years and increasing really. So we're catching up, but we're not there yet. And they have also, I guess, you have the old one? No, we don't have the old one. In my former presentations, I had an older schedule, went from 1964 to 2005, and it showed the same. Over these years, 1964, 2005, productivity in construction didn't increase whatsoever, and in any industry, any other industry, it doubled in the same time, or more, I guess, over the time. So I think I don't have to explain this, but maybe I do, because I don't know if you're in your first year or third or fifth. I guess mostly bachelor students, I guess, or not. And I think these kinds of practicalities you don't learn at university, so I'll explain a little. If a client wants a building, and this client can be, of course, a homeowner, but can also be a city or a Secretary of Defense or a hospital or whatever, management, and they want a building, they are usually contracting a project manager to develop the program of what they really want to build. And then together with the project manager, they get the architect, a structural engineer, and an MEP engineer, an MEP designer, structural designer, to design and make specifications. In Dutch it's called a bestek. Anyone knows the words? And of course then a lot of contractors can tell how much they want to build it for. That's the contract phase. And the contractor with the biggest mistake in his calculations is given the opportunity to build the project. And then, well, from a point of view from a designer, then your job is done. But most of the money is spent after that point. So when the contractor is actually selected, before that also, but when the contractor is selected, he has to cooperate with a lot of other companies. It can go up to 200, 300, 400, 500 subcontractors in projects who do all kinds of things. Can be very big subcontracts, for instance, the structural parts, but can also be painting one column, for instance. So a lot of subcontractors on site. And not only do subcontractors build or make things, but they also engineer or think things up. They design things because the specifications you have in the process from designing for the client, the specifications just have enough information inside in them to know what to build, but not to know how to build. And this how to build is done by the contractor with all his subcontractors and also the engineering companies behind them. I think, like from me, from Vericon, we do a lot of construction engineering and structural engineering. I think maybe at least, I think 70% of structural engineering costs are in the later phase and not in the first. So this is a bit of a view. Of course, there are all kinds of contracts where the contractor comes in earlier in the process or much later in the process, but the principles are still the same. This is really a slow exercise. Well, of course, I guess you know all that the design process comes from, starts with a preliminary design and then it gets more outlined to a definitive design, and at the last stage it is a technical design. The B&S doesn't say bullshit, maybe it means the same, but it actually means the Dutch word bestek. and this stack, these specifications are the set which the contractor takes his price from. And then, so this is the design process. And then after the design process, on the left side, of course, there are more design parties than only the architect and the MVP and the structural. There are more kinds of designs, but let's say this is it. And you have the contractor in the middle, and then all this design information is given to the contractor, and then the contractor is having a lot of subcontractors, and they get the same information. I use a small home for this picture, but the principle, the system goes for all buildings, of course. And you see maybe here 8 or 9 or 10 subcontractors, but like I told, there are much more of them in the building process. Well, and if all these subcontractors are starting to engineer themselves, of course, everything they do has to be checked by the contractor. So they start producing their shop drawings or detail calculations or whatever, and they start sending it to the contractor. So the contractor has to coordinate between all these different subcontractors, but also has to give this information to the designers for final checking. And of course, at a point in time, the contractor is so busy and work overloaded and hasn't got enough money or enough people to do the work. It tells them to start calling and emailing each other, and then they start emailing the architect, and then you get a big rubbish of communication. So maybe the BS in BusDeck is maybe not so wrong to say it's bullshit, because this is really a complex situation which costs a lot of money. And you might, if I show this, I don't get laugh now, but that's not a problem. But when I show this to people who have been working in construction for 10 years, they start laughing and nodding, because this is not a joke, this is actually true. Well, with our company, we try to, this is of course the result of these kinds of processes. There are a lot of, you can, like Instagram and YouTube, etc., full of these kinds of pictures and photos and films, of course. There are a lot of possibilities to do. There are so many ways to do things wrong. It's not a problem. There's always creativity in doing things wrong. So that's. But then I only talked about, well, maybe you not becoming an architect, how much money is going around in construction, how much is going wrong in construction. So why am I here? We had the idea that we had to change this all with our company, because, well, we're not maybe the biggest, but we're not the smallest. So we said to some contractors, let's do it in another way. And we did some integrated engineering in one process without all the rubbish and all the euros going the wrong way and all the communications going the wrong way. And this was quite successful. This is a small project, of course, the first time we did it. We did about, I think, all the engineering for 12 or 15 subcontractors. And then we had an evaluation with the contractor, with our customer, my customer. And I said to him, well, this went well. Are you content? Well, yes, I'm content, but you know, everything you did was on time. Yay. Everything what you did was on budget. Well, I started cheering already. Everything we assembled, we assembled without any faults. And some things weren't right, but we did them ourselves. And well, you showed us even we can do construction without work preparation. The Dutch word is werkvoorbereiders. So a whole function in the construction process is deleted by the way you work. But we're not going to continue with you. No. Well, of course, I was very much surprised. Like 4 compliments, 5 compliments, and then not with you anymore. So I asked him, why is this? Well, we think we don't have added value ourselves, so let's not do it. So technology or innovations is not always, it's a difficult way, it's difficult to get innovations really into the process for contractors or other project partners to adapt to the new ways. So I learned a lot. We did this for 2 other contractors for 7 or 8 projects, and they came to the same conclusion, that it was difficult for their own added value. So maybe I should be a contractor or something, but not. Well, I show you what we did then. This is, of course, not a difficult model. It's not a difficult building. But it's integrated engineering, because what you see here is the 3D model from the structural elements. And we derive from this model a drawing and, of course, calculations for the city, for checking. But also, from the same model, we derive shop drawings for production. So the first step of integration you can use technology for is to derive from one set of information from one set of data, different kinds of information for different purposes. This is a school in, I guess this one was in Haarlem, I don't know anymore, too long ago. And well, from afar this looks just like a building, maybe interesting, maybe not. But if you zoom in on the details, well, this is engineered to a detail on bolts and nuts size. So everything is engineered with all the rebar, all the structural elements, all the connections, all the bolts, all the nuts, all the concrete. And from this model, all the production is done, and also all this construction is done on site. And I think what is happening in construction, that we don't use the possibilities that technology offers us. I think we don't have any added value, so let's not do it in the modern way. Is something that comes up, or similar things come up a lot. Maybe we need a new generation or something in construction, I don't know. This is an example where we have like the green piles are just symbols for the cranes, which facilitate us to calculate whether every element the building is made from, you see, can be hoisted in the place it needs to be, and if the crane has the right capacity. The way it's done now by contractors is still with big drawings, drawing big circles with weight numbers on it to check whether the crane fits. While with software you can, with AI, quite easily optimize the crane, of course, which no one does. I don't know why. This is a bit of Dutch language on the sheet. I don't think there will be a small video now. You see quite difficult precast elements, they're called crown elements. And there are no two pieces of rebar in these elements that are the same. So if you have, like in a trade way, have to make these elements, they are very intensive to make, very expensive also. But if you do it with AI and simple technology, then you can make all this rebar with little time, and of course derive machine information. So from the model you can derive information that you can read into a machine that makes all the rebar itself. And this is not science or something, or future or whatever. This is done. This is done a lot, but not always from the design process. Maybe subcontractors. This machine you see on this picture is a mesh welding machine to make reinforcement. But you can put an operator at this machine who is inserting data in the terminal from this machine, and from that point makes actually the meshes. But you can also put enough data in your 3D model, export this data in the right format, and put this data in this machine. It saves an operator. For sure no one's making any faults at operating the machine. It will be quicker. It doesn't have to be done twice, etc. And this is like, there are a lot of, no, maybe not a lot, there are several these kinds of machines in the Netherlands and worldwide, of course. Most of them are made in Austria and Italy, these machines. There are only 2 companies in Europe who make these, but there's still very much operators at these machines operating them. They're not connected usually to 3D models or automated engineering or whatsoever. Well, this is maybe going a bit much into detail on the structural side of it, but you can optimize the machine time by using just the right reinforcement with the right width of the mazes. And you can, like this is some pictures from a factory who make from family homes, like you see at the bottom, small homes series, and they look the same, but they are not quite exactly the same, of course. There's all kinds of bias options in these homes, but they make the formwork and the rebar by robot, and well, we support this company with that, but not everyone is doing this. Still, not everyone is doing this because they compete with companies who do it still in a trade-light way, who still make rebar meshes by hand or with teams of people and not by robots. Well, maybe I'm going too deep now. This is a hollow core slab and a way to check them in the models, and this is a little interface in which we can check whether the machine will eat the data in the right way, will accept the data, because of course if you do some engineering, it's not enough to just give data, but you also have to format the data in a way that the machine will accept it. I told you there were just 2 machine builders in Europe like this, and the machines talk the same language, but none of these machines are all the same. If you're a different client, the machine will just be a little different, have a little bit different capacity, so you will have to make the data fit. This is what we call in English lattice girder floors. In Dutch it's called breedplaatvloeren. It's just about the same story, I guess. Precast foundation elements. It also goes for timber roofs, of course, and of course we're increasing construction in all kinds of timber, CLT, and wood frame, and this is a wood frame project. And from afar, always these roofs or wooden elements look very simple and easy, but there's a lot of detail in these elements. Usually the architect doesn't do the detailing far enough to really make it. Sometimes the architect, sometimes the contractor doesn't agree with the architect's details in terms of water tightness or air tightness or whatever, so there all kinds of changes are made. Well, we can also connect to factories who produce window frames, who connect to CRM and ERP. I don't know, does ERP say anything? Anyone knows what ERP means? Enterprise Resource Planning, ever heard of it? Well, all company, almost every company uses a system to collect all the data from production, planning, sales, etc. into one system. This is called the Enterprise Resource Planning System, and they also connect their production facilities and their production planning to it, or make it even in the ERP system. And you can imagine that if you engineer a building, if you design a building, maybe that's not already the point, but when you engineer the building for production in the later phase for the contractor, then it is interesting to connect all kinds of data to elements in order to be able to fill the enterprise resource planning system from the producers or the contractors, etc. This is not difficult, but not done a lot. I don't understand why. Well, these are few of our projects. I don't think I like the upper left one. Yes, the upper left one, I like it very much because, well, it is a bit difficult to engineer, and we did a lot for it, but they're all beautiful projects. And we do a smaller and larger one. The left bottom one are just family homes, but also there is always more complexity to the detail and to the engineering and construction than the eye meets at first. Another, I think, probably quite a few of you have heard from parametric design. Does parametric design ring any bells with anyone? No? Not? Really? Not yet, okay. So I'm the first one to tell you about parametric design. That's great. You should ask some teachers or lecturers maybe here at the TU that I think it's quite an important subject, so I hope it will come in the curriculum. And if not, I would go protest if I were you. Parametric, like we do a lot of automation at Vericon, and automation has two, maybe three if you take in production into account, but there are two main ways to do this. The first way is to really make a specific application for a specific target, like I'll show you one later. And the other way is to solve problems for others. And if you have software that solves problems, you can imagine that if you have different problems, you have different kinds of software or maybe different kinds of solutions. And parametric design with maybe Dynamo or Grasshopper or Python can help you attack different difficult problems in the most easy way. And you can use parametric design to make more design solutions for one question based on the criteria you are thinking are important, or you can do engineering jobs for complex situations that just done by hand take too much time. This is the Mall of the Netherlands, a picture changing from the facade to the structure behind the facade. It took us, with parametric design, about 6,000 man-hours to engineer this facade. I guess if we didn't have parametric design tools, it would have taken 3 or 4 times as long. Maybe it wouldn't have been possible at all. This is a little impression about, well, this is 1.5 kilometers, so each side of this, does this work? No. Each side of this facade is about 400 meters long, so to give you an idea of the scale. And this piece you see on this sheet is just, I guess, a little bit around down left there. So it's quite big. There are enormous amount of unique elements that have to be made, that have to be connected, that have to be engineered, and unique concrete elements, of course, in the facade, but also very unique steel structural elements to connect every piece of architecture to the building. And this is, if you have not heard from parametric design, you probably haven't seen pictures like this. But this is parametric design is a software tool with which you can do visual programming. So like each box you see here is a kind of computational function. And with the chords you see the lines, you connect one function to the other. So you tell the computer then the output from box 1 needs to be the input for function 2. Then the result from that needs to be, etc. So you don't need to be a hardcore programmer or developer to make these kinds of tools. Well, this is maybe more zoomed in. So the little piece of iron you see on the bottom right, I think it's 40-50 centimeters. So if you imagine that the building is 400 meters long, and each element is connected with at least 4 or 5 of these steel elements, it's a really complex job, has been. Well, this is one of the last sheets. I think it's even sound. It has sound, I guess. It's on the right, you see what we did with hardcore development. This is, it could be interpreted as being a refresh on a screen or something, but this is actually a bot software generating construction and structural engineering. So our software that we developed does all the things that I do and that you will do in the future maybe for these kinds of projects. So it does all the structural calculations. It does the 3D modeling. It generates the model. And then from the model, it derives all the 2D extracts. So all the drawings that are derived from the model are derived from the model by the bot. And this software is so complex or so intelligent that if you tell the software you will not produce it with factory A, but you will produce it with factory B, so in another factory for the concrete elements or the roof elements, etc., then it will recalculate and re-engineer automatically to be able to develop it in the to produce it in the other factory. The movies you see inserted in, the first one you saw was a homeowner walking through her future home, which was not there. And of course, this can be derived. This model information on the HoloLens she had on her head was derived from the same data that is used to make the model that we make production information from. What you see on the other insert was a director from a precast concrete factory who we provided with some software that he can put a HoloLens on, and with his HoloLens on he sees the 3D elements he has to produce in his factory. He sees the rebar he has to produce, all the inserts that are in the concrete elements, and he can check with actually by doing symbols with his hands, he can do checks whether the rebar is in the right place, has the right size, all the inserts are right, so he can do quality control from 3D based information in his factory. So this is maybe a little bit information. I think I'm at the end, just about. I just show you some different things we can do as a company at Vericon with technology. I think there are a lot of other companies doing a lot of other things too, but I don't think it's adapted just too much. So we need you to take architecture from construction, from craft to construction. I think you're the generation who has to do that because, well, if you don't, who will? So that's what and not any, of course, you're welcome to work with us, but I think it's needed for the construction industry as a whole. I don't know how much time I had available. I think I'm quite on time. If you have any questions, I'm welcome to answer them.
Yeah, I want to thank you for giving this amazing lunch lecture. And I want to thank you all for coming. If you want on my future point, you can get it at the top by the doors. And we have a little present for you for giving this lecture. Thanks a lot.